So since last lesson was kind of difficult to comprehend, we were talking about coordinate geometry, and many of you did not understand how to find the equation between 2 points. We're going to start off with some review. So the review we're gonna do is how to find the equation of 2 points. David, do you want to start off with it?
Yeah, sure. Should I just give a random 2 points?
Yeah.
Okay, yeah, we'll have the points -2, -4, and 4, 6. So let's use my method and not the weird slope thing. Yeah, okay.
Yes.
Oh, do we need a graph?
We can draw one just to visualize.
Okay. Yes, so that's where the points roughly are. So what we're gonna do first is that we're gonna find the slope. And remember, it's rise over run, so it's a y over the x. So what we can do is that we can pick the rightmost point. Yes, rise over run. So we can pick 6 minus -4. And for the bottom, we have 4 minus -2, because it's a difference in the rise, which is the difference between the y and the run, which is the difference between the x. So when we simplify this, we get 10 over 6, and that would be our slope. And we could simplify it even more, 5 over 3. So you would technically just leave that as an improper fraction. Mixed fractions are kind of weird. So, and then what we're going to do is that we're going to use y equals mx plus b equation for point intercept form, which we're going to talk about later what that means. So what we're going to do is that we're going to put, remember that the variable m stands for slope. So we're just going to put the slope in there. And then next up, you can just choose one of the 2 points, but we're just going to choose 6, 4 because it's 4, 6 because it's positive and it's nice. So we fill in the y, and then we also fill in the x. And then now we try to isolate b.
B is -2/3. Yeah.
Yep.
I
I
think so.
think that is.
Yeah. Okay.
Okay, and now we just put b back into the original y equals mx plus b with the slope, and that'll be our final equation. So it's y equals 5 over 3x minus 2 over 3.
Okay. Since we found the equation, I think it would be some good practice if we find the x and y intercepts as well. So in the form y equals mx plus b, the b is the y-intercept. So this point right here is 0, comma, negative 2/3. And how you would find the x-intercept is you would substitute y for 0. So 0 is equal to 5/3x minus 2/3. And we get 2/3 equals 5/3x. So x is 2/5. And the point at which this line intersects with the x-axis is, okay, what is it again? 2/5, comma 0. So just like what David said last time, for x-intercept, you want to substitute y equals 0. And for the y-intercept, you want to substitute x equals 0. Okay, should we move on to this lesson?
Sure. Wait, do you want to do slope point form first or general form?
I think we should do slope point form first.
Yeah, it's what we're learning right now. Okay. So yeah, this y equals mx plus b form of linear equation is called a slope intercept form. Some people might also call it a slope point form, but I don't think that's very common. So again, it's y equals mx plus b. So m is the slope and b is the y-intercept. And we can kind of get this formula by doing the thing Kevin did yesterday with the slope. So if we have the slope and the point for some reason, what we can do is that we can substitute it into a y2 minus y1 is equal to slope times x2 minus x1.
I think we should just use your form. It's easier.
Yeah, honestly, okay. Well, if you do have a slope and a point, this form is kind of easier.
Oh, okay. Maybe so we could split into two cases. So case
Yeah.
1, you want to find the equation of a line when you're given exactly 1 point and you're given a slope. So in this case, you would use what David just said, and you would use the formula y minus y of the point, so let's just call it y1, is equal to m times x minus x1, right?
Yes.
Yeah, so when you have a point x1, y1, and you have m, you would substitute x1, y1, and m back into this equation, and you would ultimately end up with another equation. So let's give an example.
Sure. If we have like the points, points 2, 3, wait, 3, 2, I mean. Actually, 2, 3 will work as well, but like,
2, 3, okay.
yeah, and then a slope of 2. Wait, I don't think that's gonna come out nice.
No, it's okay.
Oh yeah, it works. Okay. Yeah, what we can do is that we could just sub it into that slope point form, and then we get y minus 3 is equal to 2 times x minus, wait, yeah, okay, x minus 2.
Yep.
And you probably will never express it in slope point form, like y minus 3 is equal to 2 times x minus 2. You'll most likely have to reduce it down into slope intercept form, which was kind of the form that we're familiar with.
Yeah. Okay.
Yeah.
Should we give another example?
What type of example do you want?
like given a slope and a point.
A slope and a point? Okay, we could have the slope 5 and the point negative 2, 5. So we write in a slope point form, and then we could simplify it down into slope intercept.
I think that's... No, that does not seem right.
Wait.
Oh, plus 15. Yep. Okay.
I think that's all about that.
Yeah. So
Yeah,
should we move on to case 2?
Yeah.
All right, so case 2 is when you're given 2 points to find the equation instead of 1 point and a slope. Now, when you're given 2 points, you want to use the method that we talked about last lesson. So given the points x1, y1, and x2, y2, the first step you want to do is to find the slope. The second step is to choose one of the points and substitute y equals mx plus b. So when you substitute x, y, and m, you can find out what b is. The third step to find b. The third step is to just substitute b back in. So should we give an example?
Sure. Here, we could have the points 1, 3, and 3, 5. Oh, should I explain this one, or do you want to?
You can explain that.
Okay, so the first thing that we do is to find the slope, and it's rise over run. So we do 5 minus 3 divided by 3 minus 1. And what we find is 1, which is pretty nice. And then we just substitute it back into y equals mx plus b. And we just get y equals x plus b. And then what we can do is that we can just pick a random point, for example, 1, 3, and we put 3 as y and 1 as x. And then we find that b is equal to 2. And then we could just put it all back into the y equals mx plus b formula, and we just get the equation.
Yeah. We can do another example. Maybe 0, 0, and 5, 3.
Sure, okay. So again, we find the slope first. So it's y 3 minus 0 divided by the x's 5 minus 0, and we get the slope is 3 over 5. And then we could put it back into the formula, and we get y is equal to 3 over 5x plus b. And then we could pick a point. Let's not pick 0, because yeah, I don't know if that will work very well. So we could just pick 5.
It will.
Oh, it will?
No,
Okay.
it will.
Oh yeah,
Because then 0 equals 0
yeah.
plus
Oh,
b.
okay. I mean, I don't. Yeah. Okay. Maybe some of you guys realize that we didn't actually need to do the calculations for the y-intercept, but let's just do it. So we find that the y-intercept is at 0, and then we could put it all back into the equation, and we get y is equal to 3 over 5x.
All right. Do you want to talk about the general form?
Yeah. Okay. So far we learned about 2 forms, which is a slope-intercept form and the slope point form. But there's a third form that we can talk about, and it's expressed in the formula of ax plus bx plus c is equal to 0. So something to know about this form is that there's really no way to tell from just 2 points or a graph. What you have to do first is that you have to convert the points or the graph into slope-intercept form, and then change it into general form. So should we give an example?
Yeah, we can just use the y equals 3 over 5x.
Okay. Yeah, y equals 3 over 5x. So the first thing that we're going to do is that we're just going to change all the coefficients and constant into integers. So here we see that the coefficient on x is 3 over 5. So we just multiply everything by 5 to change it all into integers. And here what we do is that we try to keep one side 0. So we just move all the variables, all the constants into one side. And here we have a basic general form where the c is 0.
Yeah, so the coefficient of x has to be positive. So if it's not positive, then you want to remove everything to the other side and basically flip everything. Just as an extra note.
Here, we can try another one.
Sure.
Yeah, we can have we can already have a slope intercept form, like y equals to 3x minus 4. And here what we would do is that we kind of see that the constant and the coefficients are already integers, so we don't have to do anything there. And then what we have to do is that to keep the coefficient of x positive, we just have to move the y over. So we get 3x minus y minus 4 is equal to 0. Here, should we give them an example to do?
Yes.
Okay, should we give a complicated one?
Yeah, I think I can give one. 5 over 3, well, y equals 5 over 3x plus 2 over 3. You guys should try turning that into a general form.
Edward, I think you might have to do something about the coefficient on x. Ooh, Alex, you forgot to do something with the y.
Yeah.
Edward,
yeah.
Uh-oh, Edward. Yes. And I think Alex got it right.
Yeah, Alex did, but you want to change the order of y and the constant.
Yes, remember descending degree? It's pretty nice.
Yeah.
Yes, Alex,
Yeah.
that's good.
Good job. Do you want to explain it, or should I just like speed run it?
You want to speedrun it? Go for it.
Yeah. Okay. So the first thing is to get rid of the denominator. That's pretty much the whole point of general form. So multiply both sides by 3. Oh, why is my... Wait a second. Why is my pencil not working?
Wait, Edward, what do you mean by original? Oh, like your original response?
Yeah, Edward, if you flipped it, it will be completely fine.
Yeah.
Just try yeah. As long as one side is 0, you're all fine. You're all set. Okay.
Did your Apple Pen die?
No, it just got disconnected.
Okay. Oh, that's sweet.
Okay. So multiply 3 on both sides to get 3y equals 5x plus 2. Since we want the coefficient of x to be positive, we will do 5x minus 3y plus 2 is 0. So yeah, you want to have the first term to be x, second term to be y, third term to be a constant, and you want the coefficient of x to be positive. So that's the general form. And to be honest, the general form for a linear function isn't really, it's pretty useless. But when you get to quadratics, you want to work with the general form, which we'll talk about later, I think. Okay. Do you want to move on to the next one?
Or do you want to do another example?
Sure.
Should we like go from 2 points to general form? Should we leave them that?
Oh yeah, that's fine.
Yeah, okay. Let's get 2 points, like -3, 1 and 3, 3, -3, 1 and 3, 3. And you guys can try to convert that into general form. It'll take a while, but if you got the answer, you can put it in chat.
B is 0. That could happen sometimes. Not in this case, actually.
Yeah.
But B could be 0 in some cases. Okay. So the first step is to convert it into a slope-intercept form. We find the slope. M is 3 minus 1 divided by 3 minus negative 3. So it's 2 over 6. And then, David, do you want to like start from here?
Yeah, okay. So we kind of do what we did with the slope-intercept form. So we kind of put it into the slope-intercept form formula, which is y is equal to mx plus b. So we get y equals to 1 over 3x plus b. And then we could just substitute in a point. So we're just gonna pick 3, 3 because it's nice. We get 3 is equal to 3 over 3, 1 over 3 times 3 plus b. And then here we see that we get 3 is equal to 1 plus b. And we get b is equal to 2. Yeah, and then we can put it back into the original equation. And here we see that we have to cancel out the 3 in the denominator. So we multiply everything by 3. Oh, I got there, but my huge brain turned into a 3 for some reason. Oh well, it's fine. Yep, and then we get 3y is equal to x plus 6, and then we don't move the y because it's already positive. No, don't move the x because it's already positive. We just move the y over, and we get the general form.
Yeah.
Yeah,
Okay.
that was a long process.
It is. I guess I can start with the introduction of parallel and perpendicular lines.
Yes, that sounds good.
Okay. So on a graph, I'm pretty sure you guys all learned this in junior high, but just as a refresher, a parallel line means the distance between the two lines remain the same forever. So for example, these two are parallel lines because the distance from one line to the other stays constant forever. Now for parallel lines, for the equations of parallel lines, the slopes are the same. So the slope, actually, I'll just write m1 equals m2. So for parallel lines, it doesn't matter what their b is. All it matters is that their slopes remain the same. So for example, if we have y equals 3 over 2x plus 1, and we have a y equals 3 over 2x minus 2 over 3, then these are parallel lines because their slopes are the same. For perpendicular lines, intersect each other at 90 degrees. So for example, these two are perpendicular lines because they intersect each other at 90 degrees. Now for perpendicular lines, M1 is the negative inverse of the other slope. So for example, if we have y equals 3 over 2 x plus 1, and then another line is y equals negative 2 over 3x minus 2, then these are perpendicular lines because M1 is the negative inverse of another. Oh yeah, so for parallel lines, it doesn't matter what their b value is. Like, I can change this to like negative 1,000 and they'll still be parallel. Only the slope matters. Yeah, so the b value does not matter. And wait, give me 1 second. Okay. And in perpendicular lines, the b value also does not matter. Yeah, so both parallel and perpendicular lines, the b value does not matter, and only the slope matters, if that makes any sense. Yeah. So just remember, for parallel lines, m1 equal to m2, and for perpendicular, m1 equals to negative 1 over m2. All right, David, do you want to do some examples?
Yeah, sure. Okay. So we can try a parallel first. So we can try to find a line which passes through the point 1, 1 and is parallel to the line y equals 3x plus 5. Yes, so you just flip the fraction and then turn it negative. Or just, if it's positive, you make it negative. If it's negative, you make it positive. Yeah, so it's the inverse. Should we do this one together or?
I guess, sure. Actually, we should just let them try. That's fine.
Okay, yeah. Here, find the equation of a line which passes through that point and is parallel to that other line.
I guess we can start doing it because.
Yeah.
Okay.
Y equals to 3x. Yeah, you're getting there. You got the slope correct.
Yes.
No,
No.
because it passes through the point 1, 1.
Okay, David, we should just like start doing this example.
Oh, okay, yeah. So the first thing that we notice is that it's parallel to this other line. So what we can simply do is that we don't have to calculate the slope. We can just take it from the other line, which is, so the slope is 3. And then we can also know that it intersects the point 1, 1. So what we can do is that we could create a equation where we solve for b. So we get y is equal to, y minus 1 is equal to 3 times x minus 1. Yes, that's actually smarter than what I did.
Yeah. So if we go back, we have 1 point and 1 slope. So case 1, 1 point and 1 slope, and we use this equation right here. Right. Okay. We can have another example for you guys to try. Let's say a line passes through 2, 3, and it is perpendicular to y equals 5 over 3x plus 1. Find the equation of the line. And you can type your answer to the chat when you're done. Negative 3 over 5 x plus 1. Negative 3 over 5 x plus 21 over 5. Okay, so we got two different answers here. So we'll just work through it together. Since it is perpendicular to y equals 5 over 3x plus 1, we know that dm is the negative inverse of 5 over 3. So it's negative 3 over 5. Passes through 2, 3. So then we can just substitute y minus 3 is negative 3 over 5 times x minus 5 times x minus 2. So we get y is negative 3 over 5x plus 6 over 5 plus 3. So we have y is negative 3 over 5x plus 21 over 5. So yeah, Alex, you did it right. Good job. Edward, you're really close. Just make sure you expand the b. You expand it to get b. Yeah. Okay. Should we like move on to collinear?
Sure.
Okay.
Yes.
This will be the last topic, I believe. So yeah, so we'll just do some worksheets at the end.
Okay. So what collinear means is that the points are on the same line. So for example, if we have 2 points, they're technically always on the same line because you can always draw a line through them. However, if we have if we have 3 or more points, they have to be all lined up to be called collinear. So we can do a simple drawing of that. So you can have 2 points, they're always collinear, and these 3 points will always be collinear. And 4, we could keep adding, and as long as they all obey the same equation, I would say,
Yeah.
they would be collinear. Yeah, so you see all these points passes through the line, maybe not that one, but we're just gonna assume it's passing through it.
It's not perfect, but it works.
Yeah. So another way to think of it is that the slope between all the points are the same. So for example, if we just choose 2 random points and we find their slope, for example, if their slope is 2, and then we pick another 2 random points and their slope is also 2 as well, then we can assume those points are collinear.
Yeah. So how you would determine if 3 or more points are on the same line or collinear, you would just simply find the slope between each 2 consecutive point and see if they equal each other. So we can do a simple example. So for example, 1, 1, 2, 2, 3, 3, and 4, 4. When we see the slope between each of these 2 points, we see that they're all equal to 1, which means that they're collinear. Should we like give a one that includes a variable?
Yeah, okay. So yeah. So we can do if we have a point 1, 1 and another point which is K7 and another point which is 410, and these 3 points are collinear, what is the value of K? Wait, so are we going to do this one together or should we just leave it to them?
Oh, we should just leave it to them.
Oh, okay. Yeah, so remember that if it's collinear, the slope between all the points are the same. So that's going to be quite useful.
3.
I think that's correct.
Yeah,
Wait,
that's correct.
yeah.
I think so, yeah.
Here, we should actually do it to check.
Yes, of course.
Yes, okay. So what we're gonna do is that we're gonna find two slopes essentially, and one of the slopes is gonna have a k, so we can isolate the k. So what we can do is that we could calculate the slope between the second point and the first point. So 7 minus 1 divided by k minus 1. And then what we can do is that we can find the slope of 2 points that it's already known. So we could find the slope between 1, 1 and 4, 10. So you get
Wow,
10
wait, David.
Wait, yes?
I think that's a bit complex for right now. We should just do 10 minus 7 equals 4 minus k. Right?
Yeah, good idea.
We want to be like consistent. I guess that's so like that. Because you just want to find the slope between two consecutive points, and they just have to be equal. Okay. Do you wanna like how to solve it?
Yes, so we can first simplify the subtraction. So we get 6 over k minus 1 is equal to 3 over 4 minus k. And then we could do cross multiplication. So you get 3 times k minus 1 and 6 times 4 minus k. And then we could simplify these down. We get 24 minus 6k and 3k minus 3. And then we could isolate the k. So we get, is that 9k equals to 27? Okay, then k is equal to 3.
Oh yeah, good job. I think we could do the 0, 1, 1k 4 9 h. I think that's good.
Then would the slope also be 3?
No, the slope wouldn't
No.
necessarily be 3.
Yeah, 3 is just the x for one of the points.
Yeah, to find the slope, you would substitute k back in. So we have 1, 1, and 3, 7. So the slope would be 7 minus 1 over 3 minus 1. So it would be 3. Anyways, David, do you want to do the 0, 1, 1k 4 9 h 13 one?
Wait, which one?
Like the last example?
Okay, yeah, that works.
Okay.
Yeah, this is going to be a long one.
Yes.
Yes, so we have all these points and they're all collinear. Sure, let's try to do this efficiently. Okay, so we kind of know 2 points where it doesn't contain variables. And since we know that all these points are collinear, then the slope between those 2 points will be equal to the slope of the rest of the points. So what we can do is that we could try to find the slope between 0, 1, and 4, 9.
Okay, that's not really consistent, but we could do that for the sake of simplicity, I guess.
Yeah. I mean, we're going to have to do the slope twice anyway, so.
Oh, that's true.
Yeah, so we got to find the slope between those 2 points. So it's rise over 1, 9 minus 1 divided by 4 minus 0. And we get 8 over 4, which is 2. And then here we could just find, let's try to find k first. So what we can do is that we can do the slope between 1k and 0, 1. So we can do k minus 1 divided by 0 minus 1. Oh yeah, 1, wait. Yeah, wait, okay, I was just confused. Yeah, 1 minus 0, and that would be equal to 2. So here we can simplify a little bit. We get k minus 1 is equal to 2, and k is equal to 3. And then now we can try to find h. So we can do 13h and 0, 1. So we have 13 minus 1 divided by h minus 0, which is just h, which is equal to 2. And then we can simplify a little bit. We get 12 over h. And then here we just get h is equal to 6.
Oh, Edward, you've done nothing wrong. You just need to substitute the 3 back in to find the slope. Okay, so in this example, we asked what k is to find the value of k. You did that part correctly, and you found out that k is 3. Wait. Okay, yeah, k is 3. So then what you want to do is just substitute k back in to find the slope. No, you did everything right.
Wait, the slope for that question is 3 though.
Yeah. No, but k is also 3. They're
Oh
the
yeah,
same.
okay. Wait, I think we misinterpreted Edward because since he said then would the slope also be 3? Okay.
Oh,
Yeah,
yeah.
sorry,
Okay.
Edward.
Oh yeah.
I think we
Okay, we
misread.
misinterpreted it.
Yeah, you did nothing wrong. We
Yeah.
did something wrong. Okay. Should we do another example for them to do?
Yeah. Just a simpler one.
Okay, we can do a -1, 4. -1, 4, 1k, and 2, -1. And those points are collinear, and try to find what the value of k is.
That's an interesting equation. Equals dot.
Wait, 2/3? We're getting a mixed result of answers.
Yes. Okay. Since both of you agree that it's 2/3, it's probably 2/3, but we can just do the exam, do the example together, just to make sure.
Yes.
So this right here is the slope of the first 2 points, and the slope here is the slope of the second and the third point. So k is 2/3. So yeah, good job. Should we go on the worksheets now?
Yeah, I think we can. Yeah, that was pretty much the lesson, so we're just going to do some practice.
Yes.
What's like something interesting?
You can choose.
We can do the graphs because we haven't done anything involving graphs yet.
Oh, okay. Yeah, that's
Yeah.
fair.
Here, I don't know if they can really read the points.
No, they can, because honestly, this one is just saying the y-intercept is 2 and the x-intercept is 6.
Okay, yeah, that's really easy.
Yeah.
Here, do you want it as slope intercept or general?
General, I guess.
Okay, yeah. Here, determine the equation of this graph, but in general form.
Just use these two.
Yeah, that also works.
So Edward has an answer. Let's see if he's correct. Oh yeah, Edward, when you have the general form, you could actually like extract out the greatest common divisor, so you can divide both side by 2. Well, I think that's correct. So if we have to form y equals mx of b, we already know what b is because that's just the y-intercept, so b is 2. And then we can find out m by substituting in the x-intercept. So 0 is m times 6 plus 2. M is -1/3. So y is -1/3x plus 2. Then to turn it into general form, we just have x minus 3y plus 2 is 0. I think. No, plus 6 is 0.
Oh wait, yeah, Edward, I
Wait.
think you messed up the sign. Oh wait, and
Yeah.
okay, wait,
Wait, am I
something's
wrong?
wrong.
Wait, am I wrong? Am I wrong?
Wait, we got 3y is equal to -x plus 6. No, I think you are right. Yeah, I think you're right.
Let's
Wait,
see.
it's -6, isn't it?
Oh yeah. Wait, what?
Wait.
3y is -x.
Wait, y is positive, the constant is negative, and x is positive.
Oh, okay, yeah.
We are all getting confused.
That's fine.
Edward, I'm not sure where you got that 18 from, but I don't think that's correct.
Yeah.
So wait, did we do something wrong?
No, I don't think so.
Okay.
Because I know this form is correct for sure.
Yeah,
Because when you
Edward.
plug in 6.
Edward, the x is off. Wait.
Wait, Edward, did you get to
Huh.
this form? Like this equation? Yeah, you did? Okay. So multiply both sides by 3.
Oh, okay. Yeah, that makes sense.
Oh, okay. You want to do -6/2, not 2/6. Or wait, what?
Wait, Kevin, I don't think that was correct.
Yeah, just multiply everything by 3.
Yeah.
That's the most simple way to do it. We can do like one more.
Do you want to do the true or false questions?
Where is it?
Wait, scroll down. Oh, it's number. Wait, too far. I think it's number 7. Yeah, number 7.
Oh, okay. I think we just do one big question.
Okay.
So like 6 maybe or something.
Yeah, I think that'll work.
Okay, sure. X plus 3y plus 2. Close, but not quite. You forgot to multiply the 2 by 3.
Yeah.
2 by -3. Yeah. Yes. No.
Yes, -6.
Yeah. Okay, so since we have 4 minutes left, we'll just do this one together. Okay.
Okay, should I do it?
Wait, I don't really understand this question though, because
Oh. Okay. Well, line
okay,
AB.
let's
Yeah.
draw it out first.
So we have the line AB, which passes through the origin and intersects the point 2, 6.
If the 2 lines intersects at 2, 6.
And then CD is perpendicular to the AB line and also intersects at 2, 6.
Oh, okay.
And then we're just trying to find the x-intercept. Yeah, so we can try first finding the equation of line AB. Actually, we don't need
We
to
find the slope.
Yeah, that also works. Yeah. Okay, slope of AB. So we have a point, which is 6, and then we also have 0, 0. So we get the slope is 3. And then what we do is that we remember when a line is perpendicular, the slope is a negative reciprocal. So in this case, it's -1/3. So we can just try to find, do we need to find the equation?
Yeah, we need to find the x-intercept.
Okay, yeah, that's
so
true.
Yeah.
Wait, we can just do what we did with the collinear thing, where we just match the slope.
Oh yeah. Okay, that,
Want to do
I
that?
think this method is easier.
Okay, yeah. So let's find the equation, I guess.
Yes.
Y is equal to -1/3x.
Wait, are we
Okay.
doing? We have 1 point and 1 slope, so
Oh yeah, that's
you.
true. Okay. Yeah, let's do case 1 from the lesson. Okay, yeah, y minus 6 equals to -1/3 times x minus 2. So yeah, get -1/3x plus 20/3. And then we know that for the x-intercept, the y is equal to 0. So we could just put the 0 as a y, and then we can just isolate the x. If it's case 1, you can still do, yeah, you can still do y equals mx plus b. But if you don't need the y-intercept, like, okay, yeah, what? If it's case 1, yeah, you can do y equals mx plus b, but it's not that efficient.
The answer is
Yeah.
20-0, right?
Yeah. Should we show the other way as well if we have time? We have 1 minute.
I don't think it's necessary. We should just learn the proper way of doing it.
Okay.
Because in school, you're always taught with case 1 and case 2.
Oh.
At least in Western.
You can, for this question, there is a simpler way to do it, but it's kind of confusing, I would say.
Oh, the collinear method?
Yeah, because you already know the slope, so you can find the slope between 2, 6 and the x-intercept. Wait, can you scroll up?
That's kind of harder for me. Oh,
Oh,
okay.
really? How you found the slope for the first question? Yeah, we just calculate this as slope using the x-intercept and the y-intercept. Oh, actually, we didn't. We just kind of plugged in the equation. Yeah, we already knew the y-intercept, so you could plug in v, and then we just put in the x-intercept, and we just isolated the slope. The b is the y-intercept. So can we zoom in on the graph?
The graph? Like this one?
Yeah. Yes. Okay. So the y-intercept is when the line hits the y-axis. So we can see that where it hits, it was at y is equal to 2. So the y-intercept is just 2. Yeah. Which is also v. So you could just put it in there without having to worry about anything.
Yeah. Okay. And then use the, yes. You use that coordinate and substitute to get the slope. Yeah.
Okay.
No.
You go. Yes.
Like this one? Oh yeah, no problem. If anyone has questions, you can also ask now.
Yeah. So class is actually over. So if you guys don't have any questions, you can just leave right now.
Can you just explain that once again? What was the question?
Oh, so you're given a graph and you want to calculate the equation.
Yeah, and we specified the equation to be in general form. So.
Thank you.
No,
Bye.
See you later, Alex.
Yeah.